Hey everybody, this is Mr. Munson, and we are in Unit 3 still. We're just going to spend a quick couple of seconds here, to be honest. Unit 3 has two concepts that we're going to be looking at. We've already done 3.1, now we're doing 3.2, which is parallel lines and perpendicular lines in the coordinate plane. This is really kind of a review subject, so this is going to be quite quick as I go through. If you need more information, you can certainly go and find more detailed explanations of this stuff, but we're going to bring it in very quickly, summarize. This is stuff that you learned in Algebra 1, and then I'm going to talk more in depth about where we're using it in geometry. Okay, so one of the things that you want to remember when we're dealing with parallel lines and perpendicular lines is basically we need to know what the slope formula is. So hopefully you have that on your formula sheet, and if not, go ahead and put it on there. Let's go ahead and get started. All right, just looking at equations of lines. These are lines that if we drew them in the coordinate plane, they'd just be simply a straight line. Okay, we're not talking circles or anything like that, just basic stuff. And so, as part of our real quick review, I have 4 equations here, and 2 of them, if I graphed them, I would find out that they're parallel. Okay, so the way I can identify that is simply by looking at the slope which appears in front of the x. If the slopes are the same, then the lines are parallel. Okay? Obviously, you can see that these two slopes, 3/5 and 5/3, are not the same. So those two lines are not parallel. These two are. Okay, so now let's take a look at perpendicular lines. Perpendicular slopes have what they call opposite reciprocals. These two are opposite. They're not opposite reciprocals. Reciprocal being you take the fraction, you flip it upside down. Okay? So this is 5/3 and negative 5/3. They're definitely opposite. One's positive, one's negative, but they're not opposite reciprocals. Now, as I look and compare to the other ones, in order to find a perpendicular slope, I need to find one that is opposite, so that's negative, to this one right here, and one that is reciprocal. And that means it becomes 3/5, okay, 3/5. Or if I was looking for the one that's perpendicular to this one, it would be a positive slope. Whoops, I don't have my x in there. I'm sorry about that. It would be a positive slope, and it would also be 3/5 as well. So let me write another equation, and you determine between these two which one it's perpendicular to. So let's go y equals negative 3/5 x minus 10. Let's make it plus 10. Okay? So looking at those 3 equations, which one would you say are the ones that are perpendicular? Okay, hopefully you recognize that 3/5 and 5/3, or I'm sorry, 5/3 and negative 3/5 are opposite reciprocals. That's what makes them perpendicular. All right, so perpendicular have opposite reciprocals. Let's go ahead and get into our notes in our notebook. All right, here we go. 3.2, parallel lines and perpendicular lines in the coordinate plane. Let's first of all make sure that you know how to graph an equation. So it might be helpful for you to grab some graph paper or just simply put an x and y axis on that. Again, I'm going to suggest that you simply watch until there seems like a good point to put it on pause and then write the notes. But try not to write notes when I'm talking. That's the beauty of the flipped classroom. You don't have to do those 2 things at one time. Okay, so let's make sure you know how to graph this. Basically, this follows the form that you learned in Algebra 1 of y equals mx plus b. M is the slope, and b is where it crosses the y-axis. Okay, so what I do is I first go down and I put a point at the negative 3 on the y-axis. Okay, and then I just simply walk using my slope. Remember, it's rise over run, so I'm going to go up 3. 1, 2, 3, and then it's a positive 5, so I'll go in the positive 5 direction. 1, 2, 3, 4, 5. And I put down another point, and then I'll just simply draw that line. And that's graphing a line. Okay? Now, what I would want to point out just real quickly, again, cursory, we're just going to quickly talk about this. If you look at the 3/5 here, that is a positive. So as you can look at the line I drew, that's a positive slope. Right? That's a positive slope. Negative slopes come down the other way. So this would be a negative slope kind of equation, right? So that would be negative, and this is a positive. Okay? Make sure that you understand that. Okay, so we'll need to be able to write the equation of a line as well. So kind of working backwards than what we just did. So what we're going to do is remember that it's y equals mx plus b, and we'll have to look at that line and get the information. So let's start with, where does it cross the y-axis? It crosses at -2. So I'm just going to go ahead and put that in for the b. Now it's a matter of finding the slope. So I'm just going to simply walk from one of the points to the other point, and then label it as I go. So I go up 2, and then I go over 1, 2, 3, 4. I went over 4, but in a left direction, so that's a negative. So remember, it's rise over run. So I have y equals 2 over -4x. I'm almost there. I need to reduce that fraction, and then I'll bring that minus sign out front. So I end up with y equals -1/2 x minus 2. And that's the equation of that line. All right, again, just review stuff. This is stuff you've done before last year. If you didn't grasp it last year, no worries. What you should do is go and find a video. You can go on Google and search it, come after school, whatever you need to do. But this is no longer algebra, this is geometry. So we're just kind of quickly looking at this stuff. Okay, in this problem, we're given, and this is one of your I can statements, that you'll be able to write an equation for an opportunity or an example where they give you a point on a line and the slope. So you have to write the equation for that. Let's make sure you understand the steps to that. Again, this is review from last year. Just when you're writing these equations, there's always two things you need. One is the slope and one is the y-intercept. Okay. Now I could certainly go and draw this line on the graph and figure out where it looks like it crosses the y-axis, but I'm going to show you a mathematical way. It's definitely a little bit more complicated, but it allows you to do it for any of the problems, and this is where I'm insisting that you do this. Now we'll use the graph to kind of check and make sure it makes sense, but let's move over to the right-hand side and make sure we know how to find the two pieces, the slope and the y-intercept, given this information. Slope is easy. It's given to us. So my first step is I go ahead and take the slope that's given and I plug it in. Now what I'm going to do is I need to find b. So I'm going to take and force an equation to go through the point 4, -3. In other words, I need to have a final equation that when I plug in the 4 and plug in the 3, it creates a real true situation. And that's easy to do. All I got to do is find my b. I'm going to take my 4 and my -3, the point that's on the line. I'm going to go ahead and plug and cover over the x and the y, and that will leave me an equation with just a b in it, and that way I can solve for it. And there we go. I just took the point that I have been given and I plugged it into the equation, and now I'm going to simply work and solve this for b. Yeah, it's nasty fractions and everything like that, but no worries, we're in geometry now. I'm going to go ahead and multiply the top by top by 4, and that gives me that -16/5 plus b. So now I just need to add 16/5 to both sides. The process is the same if it was just a regular number like 3 or 10 or something like that. I'm just going to add the opposite. So on my calculator, I took -3 plus 16/5, and it gave me a decimal. But then I told it, turning that into a fraction. I don't need to do that because I'm going to be putting it on the graph. So let's go 8.25, I think is what it is. Let me just double check that. Yep, that is it. And so b is 0.825. So now let's put that back into our equation. We have the standard form, y equals, the slope is given in this case, 4/5, x, that's a positive point, let's put a 0 in front of it, 825. Now it looks real mathematical, okay? So there's me writing an equation, given a point and a slope. Now we could just quickly go to the graph and look at that. Let's go to the A point, and we'll go, I could go down 4, and then to the, go down 4 because it's -4/5. I could go down 4, which would be the negative direction, and then the left, or to the right, which is a +5. But I'm going to put this down there. It'll be easier for me to work on that. So it's actually 4 up, 1, 2, 3, 4, and then to the left, because I now have the negative on the 5, 1, 2, 3, 4, 5. And so then when I draw that line, look at where it crosses. Now, this is an estimation. I got it crossing somewhere around, it looks like 0.25, but it should be around 0.825, almost a whole one up, okay? And that's just because I drew it. All right, very good. I think I got it right. This is a negative slope line, which makes sense because my slope in my equation that I wrote is negative. Okay. so watch this one carefully. Now we're starting to kind of do some of the stuff that I'm going to expect you to do in geometry. We're going to take those concepts we just talked about and kind of expand on them. So here I have a line and then a point not on that line. And suppose I asked you to draw an equation or draw a line that goes through that missing point. Let's call that A, just so we can refer to it. It goes through A and it's parallel to the other line. Real simple. Okay? The first thing I'm going to do is I'm going to find out the slope of the other line. I'm just going to simply walk from one of the points, and let's start with this one, and go to the other point. Okay? So this would be up 2, and then to the right 4. That's my slope, right? So the slope is equal to up 2 over 4. Let's reduce that to 1/2. So that's the slope. So every time I go up 1, I go over 2. Up 1, over 2. So I'm going to draw that. I'm going to take that and I'm just going to apply it to that other point. So it's up 1 over 2. And I'm really have enough information there now to draw it. Let's just double check. Up 1 over 2. We'll create another point. So let's draw that line. Okay, there I have a parallel line. And so I was given a point and a line, the red one. I had to come up with the slope, and then I just applied it to the other point. It's real blasted easy. So suppose I wanted to write the equation of the blue line. Well, we just did this. We've discovered what the slope is, and we could kind of eyeball where it crosses the y-axis, but that's like, Algebra 1, prior to Algebra 1 kind of thinking. We want to know exactly where it crosses. So let's write the equation for this one. I'm going to suggest that you always write down the y equals mx plus b so you see what it is that you need. I need 2 pieces of information. I need the slope, and I need the y-intercept. The y-intercept we're going to have to calculate. The slope, I just calculated it to be 1/2. So let's put that in and rewrite the equation. So now all I got to do is find the b. I'm going to do that by taking the point A, right? That's a point on the blue line. I'm going to plug it in. Just plug in that number. So let's go calculate what A is. All right, it looks like A is over 1 up 2. Okay? So now what I'm going to do is I'm going to take that point and I'm plugging in my equation that I'm almost done with, and I'm going to calculate to see what B is. So I'll put in the 2 for the y, and then the 1/2 is the slope times a 1 plus the B. And that's 2 equals 1/2 plus B. So B, after subtracting 1/2, is equal to 1.5, or 3/2. I like 3/2 because we're in geometry and a little higher level, we can deal with improper fractions. All right, so I'll go ahead and finalize my equation. I'm saying the blue line is 1/2 x plus 3/2. Some clues for me to feel comfortable I got the right one is I see the 1/2 as a positive slope and the blue line is a positive slope. I see the 3/2 where it crosses the y-axis, and if I look, hey, it's pretty close to that, 1.5. All right, let's move on. All right, so given this problem, I have 2 lines, L and T, 2 points on each one of these lines, and it says prove that the 2 lines are parallel. The way we prove that lines are parallel in the coordinate plane is to look at their slopes, okay? Now, when we in 3.1, we talked about showing that lines are parallel by looking at alternate interior angles, alternate exterior angles, corresponding consecutive interior angles, and things like that to kind of look to see if stuff was congruent or supplementary and things like that. But in the coordinate plane, we're going to simply look at the 2 lines' slopes and determine if they're parallel or not. All right, so there's our slope formula. Let's find each one of the slopes. So what I'm going to do is I'm going to write an M for the slope, and then I'll write the line number or letter underneath it, like there's a subscript to kind of keep track. Order is really important, okay? It doesn't matter which one's Y2. It doesn't matter if you pull it from here or pull it from here first, okay? But wherever you draw the Y2 from, the very first number, you got to draw its X first. So for instance, let's go 5 minus a -1. So I drew the Y from the second, from point B, so I have to draw the X from there first as well, minus a -2. Okay, so of course the minus signs become positives, and we're looking at 6/5. Okay, now let's check MT. Put me on pause. Go see if you can do the slope for MT on your own, and then we'll look at the slopes and see if they tell us they're parallel or not. And there we have it. The 2 slopes are identical, and so I have to conclude that the lines are parallel. Let's write that up. And there you have it. Lines T and L are parallel because their slopes are the same. Quickly, we're just going to talk about parallel lines. Parallel lines are two lines whose slopes are opposite reciprocal. So let's just make sure we understand. So here's two lines. The slope of the green one is equal to 3/5. I just grabbed the number in front of X. I could care less about where the B is. I'm just simply looking at the slopes. And then when I look at the other one, -5/3. Now, these are opposite reciprocals. What I mean by that is opposite reciprocals kind of play this game. Basically, if you have some fraction A over B, then the opposite reciprocal is opposite of B over A. You flip the fraction and you take the opposite. So if you start off with a negative number, the opposite reciprocal turns out to be a positive number. And if you have a number on top on the original slope, then it should be on the bottom of the opposite reciprocal. Okay? So just quickly looking at an example in the coordinate plane, we can check to see if lines are perpendicular. Okay, take a look at these two lines. Right? Visually, I'm looking to see if they're parallel or perpendicular. Now, I got to tell you, since they cross the way they do, I'm not even going to check to see if they're parallel or expect them to be parallel. But let's check to see if they're perpendicular. Now, to do that, I'm going to find each one of their slopes, and then I'll see if they're opposite reciprocals. Put me on pause and see if you can find the slope of the red line and slope of the green line. You can use the points, or you can use the graph to go up and over and all those things. Okay, so go ahead and do that. Put me on pause, come back and check with me. Okay, and there you have it. I have -2/3 and 2/3. Now, I'm pretty comfortable with those slopes because one's negative and one's positive, just as my lines are negative, the red one's negative, and the green one's positive. The problem is they're not reciprocals. They're opposites, but not reciprocals. Okay, so here's another one. Are these two lines perpendicular? Check that, okay? Go ahead and put me on pause, find their slopes, and compare them. Okay, so if you came to this place and you're like, man, I can't read what those points are, I just threw them in for you, okay? This one's up here at 4,2. All right, so if that was the only thing that held you from doing this on your own, go ahead and put me on pause again, and go ahead and come back in just a few minutes when you're done. Okay, so for ML, I got -4 over -3, which reduces, because they're both negatives, to just a positive 4/3. Okay, now these are definitely opposite reciprocals, right? The numbers are flipped, and one's positive, one's negative. So I conclude these two lines are perpendicular. All right, there you have it. Don't forget to write your summary. And then here's your do it problems. I'll zoom in so you can see them better. These should be pretty fast and easy for you, okay? So in number 1, I'm basically asking for the slope between A and B. Number 2, write a slope that would be perpendicular to a slope in number 1 that you just did, and then state the reason why it's perpendicular. Number 3, which of the two equations that are written below in the green are parallel, and then state a reason why. And then number 4, which two equations in number 3, the one you just did, the green ones, are perpendicular, and then state your reason why. Let me zoom in, and then you can get going. And there you have it. Thanks for sticking around for so long. See you later.